Winter, the coldest time of the year. Everything is covered in snow and ice. The wind chill only makes it colder, weakening the bee cluster's precise thermoregulation system. After 140 million years of evolution, the bee has perfected the biological harmony of this complex superorganism, whereby individual bees raise the temperature of the cluster by contracting and vibrating their chest muscles. The thermal homeostasis of ectothermic and endothermic bee clusters is achieved by all members of the colony working together. In the summer months, the division of work is clearly defined, but during the winter months, all of the bees are focused on a common goal: survival.
Visiting the apiaries during the winter to inspect the condition of the bee colonies is essential to the planning of the upcoming production period. Quick inspections of some number of colonies in different locations will provide a clear picture of the overall strength of the colonies. In order to get real insight into the size of the clusters, the number of occupied frames must be checked, as well as the depth of the cluster. Disturbing the colonies at this stage is not desirable, but if there are any doubts, the food reserves and strength of the cluster should be checked. Healthy colonies have an insignificant number of bee deaths during the winter months. The calm behavior of the bees on the surface of the cluster is a good indicator of the general strength of the colony. After inspecting the colonies, we continue with the usual winter preparations. Winter is an important part of the year when all the essential materials must be prepared. Timely preparations during the winter months will significantly facilitate the season's production. During the season, most of the available time is spent solely on the bees. At the end of the day, the frames are packed in a template, 10 at a time. During the winter, close to 50,000 completed frames are stored. Upon completing this, we move on to the next activity, food preparation. Food is the main prerequisite for obtaining quality queen bees, nucleus colonies, and queen cells. We prepare the food intended for production ourselves so as to be sure of its quality. The food is packed in bags, which are then stored in plastic buckets. The amount of food prepared is determined by the production plan. Correctly made food contains about 18% water, while the amount of HMF should be below 1%. Our experience and trials show that food prepared in this manner gives better results than conventional sugar syrup. It also frees up the bees of the extra work required to lower the amount of water when using sugar syrup made in the ratio of 1:1 or 2:1. Apart from that, a syrup of this density is not susceptible to fermentation, spoilage, or freezing. The syrup is composed of water, sugar, and honey. The final syrup, intended for queen cell builder colonies, drone colonies, as well as colonies containing breeder queens, contains up to 50% honey, while in the pre-winter it is up to 30%. The process of obtaining the syrup takes around 4 days. The neatly arranged food waits for the big season ahead, along with the pollen patties. In the preparation of the food, we use pollen and honey from trusted sources in order to minimize the chances of contamination. Should any biological contamination occur, the only solution is sterilization, which in Serbia is possible at the radiation unit for industrial sterilization. In the second half of the winter, most of our time is devoted to preparing queen cell wax cups. Making queen cell wax cups requires the wax's temperature to be controlled precisely so that the entire process runs smoothly. Unlike conventional wax melter, the one we use contains oil instead of water, making it possible to sterilize the wax. Pouring out the cell cups is done at a temperature of 80 degrees Celsius, while gluing the wooden squares and cell cups requires a significantly higher temperature. After gluing, the alignment of the frames can be adjusted where necessary so that they are all ordered and of equal height. The cell bars are then stacked into boxes to facilitate easier handling and storage until the season starts. For the needs of our business, we prepare close to 50,000 cell cups, which will be used in the production of queen bees, queen cells, and royal jelly. The wax cups, food, and frames are now ready for the season. What's left is to fill the queen's cage with sugar and honey candy and to pack it in hermetically sealed bags. Nature is slowly awakening. The flower's stamens start producing pollen. The last days of winter are the hardest in the struggle of overwintering. Maintaining the temperature of the first brood further drains the bees. The need for the cleansing flight and water grows quickly. For us, this is when we begin working directly with the bees. In our trailer, we have heating. By using thermographic cameras, we can evaluate the general condition of the bees, as well as any deaths. The heated trailer makes it easier for the bees to bring honey from the outer frames closer to the brood, and for them to go on a cleansing flight when needed. As long as the colonies are feeding, the bees have easier access to the food. Unlike the hives in the trailer, the outside colonies maintain a tight cluster. Within the trailer, the chances of getting a chilled brood are small. The heating has a stimulative effect on the bees, and this is the main reason why we can start grafting for the royal jelly in the trailer as early as the beginning of April. Despite the cold outside, the bees are comfortable in the warmth of the trailer. The weather is changing. The days become noticeably warmer. The final preparations are underway. To protect the container, we use an insulating coating. The summer heat affects the microclimate of the colonies, while the sun beats down on the exposed hives, raising the internal temperature to above 38 degrees, resulting in the formation of bee beards. By using this coating, we protect the hives from overheating, which can cause huge problems in the production process. The parts of the hives that are exposed to the summer sun overheat, and the temperature of the roofs of the hives can get above 60 degrees. Each year, in accordance with our needs, we protect some part of the hives with this coating, a modern nanotechnology, which guarantees protection equivalent to 5 centimeters of styrofoam from a 1 millimeter coating, as per the coating specifications. After paraffin dipping, new hives are protected in the same way while they are still warm. The first flowers slowly start to bloom. After a long winter, the first intake of pollen begins. Access to water is incredibly important. Meadows and fruit buds acquire the color of chlorophyll. Each colony's strength is determined and noted. The first spring inspection of all apiaries is a must. The smell of saturated air coming from hives is a long-awaited moment. The bees are playful. The older generations are gradually replaced by hatching new brood. Colonies that are winterized on a smaller number of frames will soon receive new frames. With the flowering of fruits underway, the colonies develop rapidly. Additional chambers are added with uncapping honey frames. The uncapped frames with incoming fresh nectar greatly stimulate the development of the colonies. A strong pollen intake correlates positively to the amount of brood and the wax gland's activity. This is the moment to obtain valuable drone combs. The honey frames are lifted into the second chamber, and now empty spaces are replaced with wax foundations. Very quickly, the frames are drawn and occupied by young bees. The adding of frames with wax foundations is very enjoyable for both the beekeepers and the bees. The priorities of expanding the bee colony space is now determined by the strength of the colonies, as evidenced in the first spring inspection, in combination with the daily intake recorded with beekeeping SMS scales. After all of the colonies have been expanded, the condition of chosen monocultures must be inspected. Following this is the search for quality foraging opportunities, and deals are struck with farmers for new apiary sites. A good location is essential for creating strong colonies. Meanwhile, the royal jelly production taking place in the trailer is entering its final phase. The jelly production is done so that we can select which colonies will take part in producing queen cells. The amount of jelly per queen cell varies from 150 milligrams to over 500 milligrams. The amount of jelly produced per cell is important in the process of producing new queen bees. All colonies producing small amounts of royal jelly are replaced with new ones. After repeating this several times, the strongest colonies are used as breeding colonies, and we move on to queen cell production. Daily nectar intake increases sharply, leading frames become pollen-bound. Oilseed rape is in peak bloom. Since the weather has stabilized, jelly production and colony selection can now be done outside of the trailer under clear skies. Well-fed queen cells are essential to obtaining high-quality queen bees, and the amounts can be checked at different stages. If needed, the morphology of queen cells can be further analyzed with an electronic nonius and their volume measured with fine syringes. The potential breeder queen colonies receive additional testing. With the help of a computer program, we are able to calculate the number of bees in each frame, as well as create a database of photos to use in analyzing brood patterns. For example, this frame contains 472 bees, while the compactness of the frame is 95% in the best section of the frame. The cubital index is used in determining the racial purity of bees. We analyze the bees' wings using a program where the obtained values must be in accordance with set standards. The appearance of the obtained bell curve as a result of the analysis provides a clearer picture of the homogeneity of the sample when compared with the mean value of the index. If two bell curves are produced, this indicates that the bees are a product of crossbreeding. Colonies such as these are not considered in further selections, even if they had good production results. We also assess race purity by determining to what degree the turgide is colored, where the maximum value is 2%. In this case, the tested characteristics of this queen bee are quite good. However, there is a large number of colored bees, whereas in this breeder queen colony, the percentage of colored bees is much smaller. The overall health, as well as the levels of varroa and nosema infestations, are specially recorded. A queen bee's body weight is one of the main indicators of her quality. It should be noted that the weight of queen bees varies, and in the first 1 or 2 days can lose up to 40 milligrams, while the weight of mated queens varies with the time of the year. With this in mind, it is clear that the width of a queen bee's thorax is a very useful parameter to observe, as it does not change throughout her life. The results from reproductive morphological testing of the daughters of potential breeder queen colonies provide further insight into the selection process. After dissecting the queen bee, we separate the ovaries, allowing us to determine the exact number of ovarioles. The reproductive capacity of a queen bee greatly depends on the number of ovarioles because this is where eggs are formed. In general, the greater the mass of the ovarium, the greater the number of ovarioles, and the greater the diameter of the spermatheca, the greater the quality of the queen bee. During the production of queen cells and royal jelly, all the data is entered into our program. Entering the apiary section, we select apiary from the drop-down menu. By clicking on the hive, we can select the type of colony, whether we want to graft for royal jelly or queen cells. We can take note of all the hives ready for grafting or those which currently contain queen cells, as well as diseases and the history of the colonies. If we go with the grafting for royal jelly option, the program will automatically display the time of grafting and the number of grafted queen cells. Since this hive has not been previously grafted, we do not have data on the amounts of jelly or number of queen cells produced to date. That is the reason why this colony does not have a score. If it has been grafted, that hive would display a symbol showing that it is locked. Opening the overview section, we have the correct statistics of all the hives in all of the apiaries. For example, in hive number 36, we had twice grafted 40 queen cells, and the number of accepted queen cells was 60. The total amount of jelly collected was 25 grams, while the average is 12.5 grams. In this apiary, the total number of grafted larvae is 1,800, with 1,118 accepted, producing 466 grams of jelly. In 4 colonies, we have 67 accepted queen cells. The graphical display can also be changed, as well as the language. Queen bees that fulfill the criteria are used during the season as a source of larvae during grafting. The entire production relies on the genetics of the tested queen bees. The process of their selection is controlled by the Faculty of Agriculture, as they are the main breeding authority. Although it is a long process, the selection of the breeder queens is only the beginning of production planning. The good genetics of breeder queens needs to be supplemented with several apitechnical measures. This includes the age of the larvae during grafting, the quality of the food, the number of queen cells per colony, adequate storage of the cells, as well as many other measures related to the quality mating of queen bees. Upon collecting the queen cells, they are transported in a heated mobile incubator to the stationary incubator. If the assigned temperature and humidity cannot be maintained due to any changes occurring, the stationary incubator's alarm system will sound an alarm. The capacity of the incubator is about 5,000 queen cells. The technical setup of the incubator ensures a uniform distribution of heat, and it is accurate to 1/10 of a degree across all its levels. All of the batches are labeled so that the origin of the queen cell is known, as well as its maturity level. One must be gentle when handling queen cells, because they are very fragile in certain stages of their development. Queen cells intended for sale are transferred back to mobile incubators one day before delivery. When the queen cells have matured, they can be checked by illumination. Special cages are used for obtaining one-day-old virgin queens. It is imperative that one-day-old queens are fed with fresh honey due to both their hunger and colonization of the digestive tract. One part of the queen cells is narcotized for further testing. Queen cells intended for production and for the obtaining of naturally mated queen bees are added into 4-part 2-frame nucleus colonies. 2 to 3 weeks later, the mating success is inspected and the queens are marked. Mated queen bees are replaced with mature queen cells. While the queen production is underway, we start the production of nucleus colonies. Since the divisions are adjustable, we have more options, but which we choose depends on the demand. For example, if we have 4 mated queen bees, 2 are removed while 2 will remain. In this case, 2 sections are removed while the middle one stays. The capped brood frames from the lower colony are transferred up so as to strengthen specific nuclei or future nucleus colonies. Nucleus colonies such as these are left to further develop. While the nucleus colonies are developing, the extra queens that have been removed are used to replace last year's queen cells in the production colonies, or they are sold on. The cardboard boxes have arrived. Since the boxes are the only things that haven't been prepared during the winter months, this operation often goes on long into the night. The boxes are made of waterproof 5-layer cardboard that has double ventilation. The big boxes are intended for the colonies, while the smaller ones are for packing the nucleus colonies. Packing the nucleus colonies is a tiring and demanding undertaking. Each box must have 3 brood frames of all stages, as well as 2 frames of food. All assisting colonies are again taken to one chamber, and the surplus biological materials are used to pack nucleus colonies. All 5 frames must be well populated with bees. Nucleus colonies that do not meet our standards do not go for sale. If the nucleus colonies need to travel a longer distance, the queen bees are put in cages as a safety precaution. Since the packaging of nucleus colonies starts early in the morning, a break is always welcome. The packaged nucleus colonies are ready for delivery. They must be protected from both rain and sunlight. The nucleus colonies are full of bees. They must be transferred from the transport boxes into standard Langstroth Ruth hives. If they were to be left in the transport boxes too long, it would lead to overpopulation and complete blockage. A weak nectar flow has a positive influence on colony buildup at this time of the year. Certain hives are disassembled in the first part of the season so that last year's queen cells are transferred into big, new boxes along with the surplus brood. The rest of the brood remains in the mating nukes where the young queen bees will mate, while the boxes are shifted to other locations and protected from the rain. Those are generally temporary scaffolding or abandoned or unfinished buildings. With the right care, the colonies from these boxes can be very helpful in forming new apiaries in the second part of the season. When the time comes for them to be put to use again, the colonies will be in good condition. Separated colonies such as these are an excellent source of brood and bees for boosting both breeding and production colonies. Apart from natural mating, we also use artificial insemination for maintaining certain lines. After gathering and analyzing the data, we selected some colonies and 40 to 45 days ago added drone frames for laying. The frames were placed by adding them above the queen excluder. These excluders do not have their own entrance. If the drones have access to all of the frames, it is important that the queen excluders are placed in front of the entrances in order to prevent any potential drifting from other drones. The process of insemination is fairly straightforward, but it is all the work that precedes it and the defining of the exact breeding programs that is much more complex. The criteria for selecting drone mothers are not very different from those of the breeder queen. The only difference is that the preparation of drone mothers begins considerably earlier. The day before insemination, the queen bees were narcotized with carbon dioxide, after which we weighed them. Narcotizing is an essential step as that simulates the mating flight, with a rise in carbon dioxide of the hemolymph triggering certain hormonal changes in 5-day-old queen bees. Preparing the apparatus and activating the syringe with a capillary tube must be done only after the equipment has been sterilized. A contaminated solution in the syringe would quickly pass on to the drone sperm via the capillary tube walls. The immune system of the queen bee is weak at the spermatheca level, meaning that such queen bees cannot survive for very long in production. It is important to form 1 or 2 air gaps between the semen and the solution in the syringe. After preparations for collecting the semen, everything is disinfected one more time. Gathering drones and collecting semen is often a limiting factor. Poor apitechnical measures and untimely actions will result in infertile and immature drones with light cornua. Although they are biologically dead, these drones continue with life in the genetic sense. Inadequate and lengthy keeping of drones may result in incomplete erections along with profuse defecation. Mature drones provide about 1 microliter of semen, which is equal to the volume of 1 spermatheca. A drone sperm can be stored at room temperature for about 1 week, So in order to obtain a larger number of inseminated queens, it is better to have previously collected the semen. Depending on the amount of collected semen, the queen bee is inseminated with 8 to 12 microliters of semen. Inoculating the semen takes only a few seconds. After insemination, the queen's wings are clipped and she is marked with zircon. The inseminated queen bee must be returned to the nucleus as soon as possible, as her moving around allows for better filling of the spermatheca. A checkup is carried out 7 to 14 days after insemination. For the purposes of inseminating and obtaining mated queen bees, we use the standard LR hives, as well as mini nuclei in Farrar boxes with 3 shortened frames. The fundamental approach and methods used in this insemination process come from experiences gained in New Zealand and Slovenia. Colonies with artificially inseminated queen bees are marked, after which they are inspected again in order to determine the next generation.
The process for obtaining quality queens often requires more complex examinations. The Department of Biology at the Faculty of Veterinary Medicine can determine the presence of RNA and DNA bee pathogens, which includes viruses, bacteria, and protozoa, and they can also carry out genome analysis and determine the expression levels of certain genes. These modern molecular techniques can be used to compare different sex alleles present in a queen bee. Comparing the frequency of different forms of this gene in a given population provides a clearer representation of the degree of relatedness, which helps to reduce inbreeding in the future selection process.
Colonies with compact brood are a sign of richness and diversity in sex alleles. There is also a plan to implement a technique where fluorescent microscopes can determine the percentage of viable sperm and their concentration in the spermatheca, as well as in the collected sperm of the drones. The blooming of the sunflowers is upon us and time is running out. The days will soon be getting shorter and shorter. It's time to prepare and move on to the last forage. Fields of sunflower can be a good source of nectar and pollen. A combination of good sunflower species, nice weather, and strong bee colonies will result in a good honey harvest. The honey storage and packaging is done in the shared space of our sister company, which specializes in packaging, and honey is their main product. Registered production and the ability to store our honey in smaller packages ensures that we will be able to sell all of the honey produced. Even though honey is the main bee product, our production is mainly based on producing queen bees and nucleus colonies, as the apitechnical techniques we use don't result in large quantities of honey. Quality control of the honey is carried out in an accredited laboratory at the Serbian Institute of Veterinary Sciences. Here the amount of various sugars, HMF and diastase number are all analyzed as standard, but they also offer sophisticated instrumental methods in the diagnosis of pesticides, heavy metals, as well as the microbiology and radioactivity of honey. In the summer months, all of the extracted frames are kept in cold storage. Low temperatures are the best way to preserve them, otherwise wax moths can interfere and cause serious damage. Wax from the wax cappings is melted and used during the winter months to create cell cups. And wax moths aren't all that beekeepers have to worry about. Predators. During the dearth, bees are more prone to robbing. Apart from the obvious problems, there are also hidden ones that a beekeeper must always be aware of. Bee diseases, Varroa and Nosema. Varroa is most prevalent in the last stages of the summer, so it is imperative to closely monitor how affected your bee colonies are. Ignoring this problem will take its toll during the winter months and possibly even sooner. Varroa primarily feeds on bees' fat bodies. As a physical and biological vector of many viruses, it presents a serious problem in beekeeping. We evaluate the level of contamination by using powdered sugar. Though it may appear simple, this method is highly accurate, and every colony that is significantly affected will show it with this method. From the same sample, some of the bees are taken to check for intestinal infestations. After the sample is recorded, an exact bee count is done. After this, the bees are thoroughly crushed with a few millimeters of water. If there were 40 bees, the remaining water is poured up to 40 milliliters. Then, we use a hemocytometer to count the Nosema spores in 5 diagonal fields at a magnification of 400 times. Next are the last preparations for the winter, checking the strength and feeding. The feeding of the bee colonies follows the removing of the honeydew. The colonies reform the cluster. The final hive openings of the year are done to apply oxalic acid. At the same time, we observe and note down the colony's condition and the cluster size. Winter is coming around again. Even though Serbia is a small country by area, it actually has the most hives per person in the world. In the preserved nature of Serbia, over 1 million hives diligently work for the benefit of our planet. The mysticism and inscrutability of this gentle creature will long remain a mystery. Beekeeping is the poetry of agriculture.